All right, we're live. Well, welcome everybody to Omaha Data Science Academy SQL 101 class. I'm the Professor Jeremy Bergman, and this class is class 5 of the series, is cleaning data using SQL. So I consider this class to be the most practical and hands-on class of the series so far. When you're learning how to query and doing the other things, it is, but this is more of like, now that you have all of these skills, it's taking all these skills combined together and you start like solving a problem, specifically how you clean data if it's not necessarily the cleanest data, or if it's not the cleanest data, or sometimes you just need to do certain things to do a data science project or some analysis. You need to define some new rules on it, or recategorize states or names, or regrouping things. So this is really like the most hands-on and I think the most practical, and really like the summation of the skills that you've learned so far. All right. So how this class is structured: we took class 3 and 4 quiz and reviewed it already over last week's content. We're going to do a cleaning data overview, like why it's important and the things that we want to look for when we're cleaning data. SQL wildcards, we'll get into that for the first time. You can do certain things with text and identify like text strings, or things that start with, or character strings that start with certain characters, and then identifying and removing duplicates. So how do you identify what the duplicates are in a data set, and how can you remove those to create the result set that you want? Hour 2 will be all about data cleansing and formatting, so string, numeric, and date functions. And then at the end, we'll do lots of examples. And then we can take a chance to review any previous homework or homework 2 from last week. Okay. So review of class 4, joining and merging data. I'll go over this real quick, but we have our Venn diagrams of the different types of joins and the way you can bring 2 data sets together. Not necessarily just 2 data sets, you can bring multiple data sets together. You could have 10 different data sets, but in essence, they're all a bunch of A and B join diagrams. All Venn diagrams like this, A and B joins. Right, so you have the union, where you overlap the duplicate records, and the union all, where you keep both the results, whether they have duplicates or not. And then we did queries and subqueries. So subqueries, you always work from the inside out. You can use these in select and from and where clauses, and we saw a couple different examples of that last week. So subqueries are useful. You can have an initial set, and then you could use that result set and use that in a bigger query. So it becomes powerful when you just need a subset of data to use in your bigger query. All right. Class 5 objectives, covered this a little bit, but SQL operators, wildcards, like functions, really like looking for substring or character strings within longer character strings, looking for substrings within longer character strings. Case statements and logical functions. We know a little bit about case statements. We're really going to use those to our advantage today. And then logical functions. We'll see where they come in useful in detecting things like null, or a set of how you could use it on a set of values. Removing duplicate data, how you not just remove it, but how you can detect duplicates and then remove those accordingly. And then cleaning and formatting string, numeric, and datetime data. All right. So cleaning data, so this is a slide just about this level setting. Why is it so important? We started to talk about it, but this goes into a little more detail. I think this slide, this little graphic over here, is kind of a nice one. So they surveyed a bunch of people have to get the source for this, but what's the least enjoyable part about data science? It probably is really this combination of things. Like 78% say it's either collecting data sets and then cleaning and organizing data. These kind of go hand in hand. They often call those data wrangling. But definitely cleaning and organizing data can just be, it's not it's not the most exciting thing in the world, but it needs to be done for projects or making sure the data is accurate or the way you need it. If you don't like these other things, if you're a data scientist, I'd wonder why you're in data science, like building training sets and refining algorithms. That's like AI or what data science is all about, really. Say, I guess that says maybe like 22% of data scientists don't even like their job. But anyway, so what does clean data cleaning really mean, and kind of why it's important? So data cleaning is the process of confirming the validity, accuracy, completeness, consistency, and uniformity of data. We'll jump into what each one of those means, but you could say, is the data valid? Is it accurate? Like valid, does it produce the right results? Is it complete? Is it a complete data set? Is it consistent? Are the values what you'd expect? And then uniform. So are they produced kind of consistently, but uniformly over time or such? Becomes really important because not all systems are really designed for that. So we'll learn more about OLTP, like transaction processing versus analytical processing, next week. But oftentimes systems that are created, they aren't really designed with a thought of data. They're just more of like how the system functions. So sometimes data will be collected from a system and it's not where it needs to be for analytical purposes, or like records are constantly rewrote or data is deleted at certain time frames, and then you can't get the historical data out. You have to capture it for those purposes. So this happens a lot when you're pulling data out of systems, and that's why it's really good to be an expert at some of the systems within a business, because you can really like start to understand, like, why is a system producing these values? Why is it not consistent? Why is it not complete? And then you could go and remedy it. So how can you claim data? Like I was saying, it's often using business knowledge along with software tools or coding language to clean data. A lot of times it's just knowing like what the values are or what should be produced, knowing those systems or the business rules and logic that go behind it. You can use software tools. SQL is one of them that you can use, but you could also use Python to clean data. That's really common. If you're writing, if you wanted something that's repeatable, or you wanted to really transform it or do certain multiple steps with it, Python's a pretty good option for that. SQL is also a really good option for cleaning data that just lives within tabular databases. And that's actually usually where I start, and then I'll pull it into pandas or Python and pandas, and maybe do something I need to for a data science project with it. What about programming languages? Talked about that. Cleaning data in a language like SQL or Python gives you flexibility to run routines for specific projects while keeping the costs low. So you doing this before you get the data, or instead of doing it manually, you can use programming languages to do it. It keeps the costs low because you don't have to, every time you get a data set, like weed through all the values and change them by hand or anything like that. You can use program to take care of these things for you. So I've been there before, like every time you have to search each column and make sure all the column values are good. It'll drive you crazy. It'll make you start not liking it. So my recommendation is to automate wherever you can using SQL or Python or a combination of both. Okay, so goals of cleaning data. This is where we'll dive deeper into some of those completeness and consistency and uniqueness ideas for data quality. But some of the high-level goals of doing it that helps with completeness and consistency and uniqueness is removing unwanted observations, whether they're duplicate observations or irrelevant observations and outliers. Finally, with duplicate observations, those are often, a little more obvious. If you get a bunch of the same data for whatever reason, using like a keyword distinct or removing those from your analysis, you usually do that unless there's some reason why you want to keep duplicate observations in there. So it really depends on project that you're doing. Irrelevant observations and outliers, that's where it really starts to become expert knowledge, to know what an irrelevant observation is out of a system or a survey or whatever the data may be, and then removing outliers. So when you're doing data science projects, outliers can have a big impact on the analysis that you're doing. And there's an art, that's also where you have to decide whether you should leave that in or leave it out. Say, maybe there's a transaction of $10 million. You might, compared to like other transactions that are just like $100 or $1,000, you see this one that's 10 million. You really have to take a look at it though to say, is this just an accident? Did it just happen that way, or is there some other reason we should exclude it, or is it actually legitimate and we should be including it in our analysis? So could be for whatever reason, it could be legitimate and you decide that it's not good for your analysis or whatever you're doing, or maybe you should keep it in because it's important to note. So it really depends on the specific problem you're trying to solve. Right, so 2, fixing structural errors that occur during measurement or data transfer. This can happen within systems, especially. Measuring over time can be an issue that it doesn't keep the measurements. It could just a system tracks in a way that you don't, that's not really meant for analytical purposes also. So you might have to fix some of those errors that come with that, or maybe the system has just gone haywire and starts measuring things like crazy, or gives them a bunch of weird values. In data transfer, this can happen as you transform data, as it gets sent from systems and transformed multiple ways. That something just happens in the data set that corrupts it, and you have to fix some error or sometimes even go back to the source, but fix errors that occur when you do that. And then handling missing data. So this is like handling nulls, like what you do with those. Sometimes nulls are intentional. They don't have any values. Then you also have to determine is that legitimate or not. You can handle them in a couple different ways also you could just drop that observation. You often do that in data science projects if you're modeling something. Or probably even just as common, you impute a missing value. So what imputing is that you're kind of guessing what that value should be based on other similar values. Happens a lot in data science projects. Not always as much in just BI projects or everyday doing reports and dashboards and stuff like that. Usually you want to draw attention to those missing values and maybe have someone go fill them in or something. But you could, instead of null, maybe you know what values should go there instead, and then you fill in those values. Or you could even create another value that says, is the value missing or not, which is completely, create another column that says that, and that's completely legitimate too. There are other possible ways to clean data. but these are always performed, these steps, on any data set that you analyze. So these are just like the baseline. You always want to look if they're duplicates, if they're irrelevant values, if fix the structural errors and handle missing values. And all of these lead to completeness of data. Are all data sets and data items recorded the way you'd expect? Is it consistent? Does it match across data stores or how you would expect between systems? Uniqueness, is there a single view of the data set? Validity, or sometimes there are multiple views of the data set, but you define those. You have single views and then you define the different views of the data set. Validity, how does the data match the rules? Oftentimes, if it's a transactional system versus analytical processing system, and we'll learn more about that in 2 lectures, but the transactional system may produce it in a very different way that you need it for analytics, and those rules may be different. So does it match those? If they don't, maybe you have to define some new rules on the data or clean up the data. Then accuracy, does the data reflect the data set? So accuracy is a little more straightforward. Is it like accurately measuring customer purchases or customer churn or something like that? And that's usually you reconcile the data to the system, and then if the data doesn't reconcile the system, then you say, well, it's just which data is accurate, and that can open a can of worms too. But I would say cleaning data is about 80% even of data scientist's job. And if you go into BI, you'll be doing a lot of cleaning of data and transforming it the way you need. Even with me, my career, I've probably spent, I'd say, like, get a little bit better at it over time and automate things, but probably 70% of my time spent doing this, and 30% is like analysis and dashboards and so forth. This is a part here that's really like underappreciated, like everything that needs to go into the data just to make it a usable data set. But you make a good living and career off of it too. All right. So SQL wildcards. So we're going to start. So this was all about cleaning data to start and the purpose. And I gave you some background on some of my experience and some of the things that you may hear if you're an organization that talks about data quality, especially some of these completeness and consistency and uniqueness and defining rules around business rules around these, around data. All right, so SQL wildcards. So the purpose is this SQL-like operator is used for comparing and or substituting one or more characters in a string. So oftentimes it's like you're using the like and then you're using these symbols along with it to get like little substrings out of a longer character string. Or either you're substituting it or you're trying to match it. So you could have something in the where clause where you'd say where name is like Smith, and then you could do one of the common ones I do is %sign and %sign. That wasn't actually the greatest example. There's some better ones here on W3 schools. But usually it's like a substring that I'm trying to like search for or compare. So we'll jump into these different symbols, and through some more examples, it's going to make more sense. So the symbol %sign, this is one that I do use about 90% of the time. It's to represent 0 or more characters. So you notice if you have BL and then the %sign, it's going to look where that string is the first 2 characters, and then it can be anything after that. So the BL percentage finds BL, black, blue, and blob. The underscore represents a single character. You can see the example here. It find hot, hat, and hit. So exactly 3 characters long with anything there. It can be anything there in the middle. The 2 brackets represent any single character within brackets. So you put O and A there. So it'll find hot in the second character because of the O and the A, but it won't find hit because that's not one of the letters that we are looking for in the brackets. All right. So you have the caret. That's kind of like a not operator. So it would, in this case, it'd find hit, but it'd exclude hot and hat. And then a dash is a range of characters. So C, A through B, it'd find cat and CBT because it would do both of the, it'd go through that list. Right, that one would be useful if you were just looking for a states that start with the letter A. You could have this at the first, and then you could have the percentage at the end. So look for all starts, A and then anything, B and anything, C and anything, and so forth. So those are the main wildcards. We'll take a look at W3 schools, what they have here. If there's anything else here, they do have the brackets here, the squiggly brackets, but then they have a demo database where you can try to use all these different wildcards with the like statement. So here, like, it's like select star from customers where customer name is like this. So anywhere in that customer name, if it has MER, it will return that. I was almost going to say Jeremy, but that's not quite how you would spell my name. But they'd have like Merity. If you had something in the middle here, America, it'd return it if your name's America, I guess. that'd be a cool name, but that's the idea. Even if it's in the middle, it would return that result. Let's see what it returns here. Customer name, even if it has 3, you see an MER there in Supermercado, MER in Romero, and MER in Hipermercados. I wanted to spend just a little bit on time on that to show how that's really used. I have a few examples here on this slide. This is also in the new PowerPoint SQL file that I sent today. It'd be lecture 5, slide 8, a couple of different ways. You could really play, I always say really play around with this code, and maybe in particular with wildcards and likes and stuff like that. In particular, see what it returns on certain values. But here's a couple of examples from our data set, the world.country and world.city, is that you can go AIN with the percentage signs, and you have Bahrain, Spain, St. Lucia, because you have the AIN in the middle, or Ukraine, or St. Vincent. Then this one's kind of a silly one, but it's an example. So all cities starting with any character followed by London, or London. So exactly 7 characters long or 6 characters long. It could start with any. Of course, it'd be London, but it actually did return 2 results. And then finding countries that start with Z or K. So there's a new keyword in here. It's called regex. What is it? So regular expressions, yes. I was reading the name and I was like, what does that stand for? So you can do, instead of a like, if it starts to get complex, you can start to do regular expressions. And the regular expressions, what's confusing on the last slide is you have this one, but it works differently in regular expression. This is actually the start of your string, and it would look for any character that's Z or K in the first here in the first letter of country. So I believe I have a link. Do I have a link to regular expressions? If not, I should give that to everyone. Or we'll go ahead and pull one up. Or we'll pull this up real quick. That's close enough. MySQL regular expressions. So it's like for advanced pattern matching if you find that like doesn't fit your needs. But to be honest with you, like the like and the percentage signs, like I said, that matches like 90% of like the substrings that I look for, the strings that I look for. Occasionally I'll do one of them with the underscore if you're like really pattern matching things and you need it to be a little more flexible. But regular expressions are really like where you'll get a lot more power if you need it. It gives power search utilities in strings. And this, it uses a lot of the similar pattern matching in the characters, but it's just slightly different. You have things like this that I've never used. Matches the beginning of words. Matches a character class to match letters. But matching patterns of P1, P2, or P3. Yeah, you can really dig into it. I've honestly never used a few of these, but just bringing up that awareness that it's there, and potentially if you ever need it, you could go and dig in. You could dig further. And I'll actually keep that open so we can make a note of it for the end of class. Or put in the class notes. Okay. So one more thing before we go to break. Let's go ahead and make this full. Try to make this full screen again. All right. So removing duplicates. So the purpose is to prove the accuracy, consistency, and uniformity of data by removing identical observations that appear more than one time in SQL data. So like I was talking about, often you're trying to identify them, and not always necessarily just removing them, but trying to determine what you should do with those duplicate observations. These are a few different ways that I use to quickly be able to get to some of those. As some people in the class have, or as most people in class have used before, there's a distinct keyword to be able to tell you what the distinct value should be. And then you could use it different ways to be able to detect duplicates. And we'll see examples of that coming up. Finding duplicates by key. So you could take one data set where you count the number of duplicates and join it to another, and we'll see that. And then find duplicates by aggregation. This is using like aggregating on a certain value and seeing how many times it appears in the data set. And these are definitely ones that we should go ahead and get concrete examples of. So let's do duplicates by aggregation. So finding U.S. cities with the same name but have duplicate records. So if you were just to look at the name of the city and you do a sum and then you group by that city, because you have to when you're using column function, and then using a having statement to count where it happens more than once. That's the key right there, is that you sum them up, these values on a single column, or this could be multiple columns, and then you count how many times that instance happens. And then you filter out anything or you keep everything really has a count greater than one. Like you see, some of these would be obvious, like Kansas City. You'd have a Kansas City, Missouri, and a Kansas City, Kansas. Obviously, there are a bunch of Springfields, whether it's Illinois or what other Springfields? Springfield, Massachusetts. There's one that I'm forgetting, but Glendale's, Aurora's, are probably really a lot of Arlingtons. But in our data set, there are two. So just identifying it, and maybe underneath it's legitimate, like maybe you'd want to keep both. But maybe if you're doing a distinct list of cities, maybe you would get rid of one of these observations and keep the other. You could delete some of the observations out of there, out of the table, or out of your results that you need, or filter them out with a query. All right. So identifying duplicates by key, finding U.S. cities where the same with the same name and duplicate records. So this is we'll use a subquery on this one in duplicates by key. So we use that subquery that we had before in the last slide. And now we can use this as a table to join to our original data set and inner join. So when we inner join these cities, we only keep the records that match. So it'll only return the matching records in the bigger table. So this is where the combination of aggregation and then duplicates by key become really valuable, because you can take that result and then from your bigger data set, get only the ones that match. And now you can see Arlington, Texas, Arlington, Virginia, that's where you get the count of 2. Kansas City, Missouri, and Kansas. And then Glendale, Arizona, and California, and so forth. So that's where joining by key is valuable. They have the common key, you have the count, and then you can start seeing, well, why do we have these duplicates, and are those valid? And still, even then, it depends on your analysis. It's probably valid here to keep all of them, but maybe, like I said, you just want to count distinct city names, and all you need is one of those out of each, whatever it may be, or whatever reason the duplicate occurs. Maybe a system does duplicate transactions on some type of transaction key, and one of them ends up being an error. This is like a easier way to be able to, especially imagine if you have just millions of rows instead of like looking through all of them. You could do it this way and then join it with the other data set and get the whole list of them. And even that can be huge, but you end up starting to filter things out, and you look for themes and stuff like that. Usually it ends up being like some rule that went wrong or some certain situation. So even with data, you become part researcher. I think you're trying to figure out why those values are there, and why they're generated, and why they're duplicated, and so forth. And then you can go tell your IT guys, and they can get angry with you for noticing. All right. So using the distinct keyword, obviously the most straightforward. This removing U.S. cities with the same name or duplicate records. And everybody's pretty familiar with this. I've seen just about everyone use distinct, selecting distinct names of cities. If you're returning a data set and you have multiple columns, you'll return distinct over those multiple columns. So you could have like a Arlington, Texas, and Arlington, Virginia if you had state in this one, and you're returning distinct. But then if you had 2 Arlington, Virginias for whatever reason, it only return 1. All right, so that was a lot in the first hour. I didn't even really go run any of the code, but I'll let everybody take a break, and we can run some of these examples. We'll run through some of the examples after we take a break with the quiz and doing lecture. First hour, it's quite a bit. So take a break. We'll come back at 7:20. I'll give us about 13 minutes. We'll run through a couple of these examples since I didn't run the code. And then we'll continue with scalar functions and data numeric formatting functions, comparison and formatting functions.
actually removed, which is because it's from the table. Is that right? It's just
Right.
listing them distinctly. So you would do something like drop, right? Would you do
Yeah, if
select?
you found a table that had duplicates in it and it shouldn't be in there, then you could use a delete on it.
So if I like kind of run this and like make sure, yes, these are the ones I'm going to delete, and then like do another like subquery or whatever, like delete them, delete, and you.
Shit. Hold on 1 second. I just let this go in here. Let me move this over to the other one so we just show that's better. Okay. So how would you delete those out of a table? So yes, I would say it's only going to detect them and do that result set, and then say what would you do with that after that? Like,
Yeah,
would you remove them from a table? I generally wouldn't. We'll see in this lecture where we create a view, or maybe we do it. Maybe it's in the examples. We create a view. I would just like keep the original data and create a view that cleans everything up or removes duplicates.
So this isn't exactly cleaning it, it's just identifying it at this point.
Yeah.
Okay.
Yeah, because ultimately, once you identify it, then you have to decide what you're going to do with it. Sometimes it may be legitimate just to delete those observations out of the table, but my preference is to not do deletes on anything. So just to keep all data as it was originally produced. Because if you delete something, then it's gone. You never maybe you find out later that you need it for some reason.
So are you're saying then like take that the data that let's say that it just duplicates and stones whatever. You're saying keep a copy of that, but then like produce a new fresh one with purpose cleaned up. Okay, gotcha. So it's like what? How are we cleaning it? Really? It's like first, okay, but now that makes sense.
My tendency is to leave the raw data as it is or how it was created, just in case you ever need to go back to it. But the reason, if you created a new table, maybe you delete some records out of it, or you wouldn't insert those records, or you copy the table, you delete some out for your analysis or something. But even at that, you can really do it in a view. Just create a new data set where it leaves out the duplicates. I prefer to just create views. It gives me a lot of anxiety to run deletes. Or even updates, really. Not really inserts, because those can be easy to take back, really. It's usually easy to tell what you inserted, new records that you inserted. I don't know what's worse. I think I was debating myself last time what's worse, an update or a delete. Maybe update's worse. Especially if you haven't thoroughly tested it and it updates a bunch of stuff that you didn't expect it to update. And then you're like, well, how do we then fix the data set? And that's when the DBA works his magic and he comes up with a backup. And you get the business from the DBA. I'd like to say that I'm a professional, but doing it for 17 years, it's happened to me a lot. It's over a long time. Actually, it's smarter about creating a table or putting it in a sandbox or something and doing stuff there. especially if you work at a big corporation, and if you screw something up there, you might not have a job. And then you go, and then like if you run it and test it, you have like 3 sets of eyes on it, and then somebody else runs it, so it's not like all your fault if it goes bad. And then you have like a plan on how to reverse it if you have to do it before you make the change. They're a lot more careful than bigger companies and smaller companies are about that. If you do that in a big company, you could literally cost the company tens of thousands or millions of dollars. Not to scare anyone. Do all deletes and updates in the same box or offline and test it thoroughly. I'd rather just create a view. It's safer. And it does a view will do as a data analyst or data scientist, like a view will basically do, I'll have like all your transformations or business rules in it that you apply, and it does everything you need anyway. It does all, you clean it up. The only bad thing is if there continues to be garbage that goes into the table, and then you have to constantly write more rules and more rules to handle it. But then you have to say, well, is it a process error in the system or something, and try to get somebody to fix it, or a problem with how the data is being collected or whatever. I'm going to use the restroom real quick. I'll be just a minute. But someone's eating up that popcorn. This boy's got popcorn. I've had it for months. Still good, isn't it? Or still seems good, not stale or anything.
Yeah, I'm like, it was a little bit sour. does not.
Like $100 of popcorn and never ate any of it. All right, we'll go ahead and get restarted. We'll do that by running some of these examples that we glossed over, particularly some of those aggregation ones are finding the duplicates and then the regular expressions. So this, I just sent everyone an updated examples PowerPoint SQL. So that goes back. I went back through the other slides and made sure that the code in lectures 1 for 4 match the slide numbers all matched up and is in order. But I also added some examples here from lecture 5. So that slide that has a bunch of the like statements and regular expressions, these are definitely ones that you can play around with. You'd expect this one name like AIN to return Spain in here somewhere. But you have the Saints and everything. Those are the same ones that we ran. Highly recommend doing whatever you can with those. And then even using some regular expressions. You could do one that does, let's see, you can combine all three in one. Let's say we wanted to look for Boston. Could do the first combination is B. It could be anything in between and then ends with ON. Let's see if that gets Boston. Should. No, that didn't do it. Oh, you know why? This would only include one character if we were in the middle. B O S T O N. Boston and Boston. Oh, that didn't do it either. I have to think about that one, but you can use a combination of these. Ton Boston. Thought that would work for sure. I use like almost on almost everything. Yeah, you do. I hardly ever put these in the middle. There's Boston. That percentage sign, it does include like multiple characters, so you only see 4 there, but it's like B and then anything in between, and then ended with the last 2 characters. So you get a few of these, right? Like Brighton, Great Britain. Yeah, Brockton, Burlington.
So you do
What's that?
You do it like you did London.
Maybe it needs the caret here. See if we can return Boston and London. That didn't work either. I wonder if you might have to use that in those brackets in a regular expression in MySQL. I guess you could do like like BON or like London. Could do whether it matches either one of those. Could return Boston and London. Yeah. Bet there is a more clever way of doing that I can't think of off the top of my head, but that's the idea with those. Finding all countries where the second letter is A, B, or C. So we do regular expression. That's where you can use the brackets. Second letters A, B, or C. Yeah, so the regular expression, the syntax is a little bit different. So it starts with this hat, and then there's a dot, which excludes the first character. Then it looks at the second character is A, B, or C. So a regular expression is like something that gives you a lot more like advanced string search capabilities. If anybody does Python, they also have a regular expression function in Python that's kind of similar. It has its own syntax, and you can use all of these different, what would I call these symbols, to like do different things and different string detection and cleaning and everything. And what's that?
When I was sitting there about that, I should have said
This one?
that.
Yeah, it's either A or B or C, like Iceland. I don't know, maybe have one in here where the second letter is B. Probably not. I think you could also do, let's see if you could use two of these. See if you could do, instead of A, B, and C, you can do A, B. Yeah, you could do that. Instead of doing A, B, and C, you can do A through C, A through E. That should do A, B, C, D, and E. Now you get some of these where the second letter is E. Or C. Yeah, C is in between A and E. So you can really do, like, start doing some advanced string searches, text searches. And then if you detected one of those, you could do case when, the string, and then regular expression is this, and however you want to define it, however you want to group it or clean it up or whatever. We'll see an example of using a case statement in our examples and homework. That's like my favorite way to clean up a string, because then you start writing a bunch of rules like in a case statement, and then you say if it matches this, then clean it up this way. Okay.
So the example where you had the regular expression with the caret and then the bracket.
Yeah.
So is it different because it's a regular expression? Because in the notes it said the caret means any character not in this bracket, and then but then it's DK, and that's what brings out. I guess I'm just not sure. I'm just understanding that more.
Yeah, I might not have a very good syntax for you. I thought that you could use that in a like statement, in that caret is like a not in the like statement. But it doesn't seem like you can use those brackets in a like statement. That's how much I also use that too. But I'll take a look at that too. Yeah, it's a caret. So in the regular expressions, I'll go to this. Oh, you know what though? It's because it's inside these brackets. Inside the brackets will work. The other one was out. The example is outside of the brackets.
Okay.
In the regular
Bracket is just going down,
expression,
right?
yes.
Yeah, when it's you doing the two letters,
Oh, okay. And it brings up everything.
it is zero.
Say small difference, but
Also brings up- It would start with those things, right?
It should start.
this one would be
It should start
is
with
that
zero,
it-
okay.
it starts a regular expression, and then the first letter would be Z or K.
Isn't I put software in the brackets?
It would.
But then it brought up. Countries outside of K.
It did.
Maybe.
It should bring up everything that's not. Here, we'll go ahead and run it. Regular expression. Here's country. I changed that to A through E. We did what 2 letters? K and Z. Oh no, it's up here. CK. Okay.
You don't take anything else out, you can
That one has a different meaning. And you're saying that caret starts a regular expression. Like it does down here. It tells it like if you use the regex keyword, then that tells it to start the regular expression. And you're saying, Melinda, that there were K's in here?
Yeah.
H-I-J. I don't see any. Or I guess that mine's not sorted. Hold on.
Yeah, he has the triangle on the outside, the triangle on the inside.
Okay, one else.
Yeah, I had it good, so yeah. But you only had the one on the inside, right?
Yeah, well, first it was on the outside.
You-
Then I moved in the inside. And I didn't see that we put on this. So yeah, now it doesn't.
Yeah, it takes some getting used to the syntax.
But
Okay. It excludes K's.
that way,
Cheat sheet, and it says that
This one excludes K's and Z's. How it is right here. So this just starts a regular expression, this caret, and then if it's inside the brackets, it's not Z or K. And I sorted these, and they're no H, I, J, K.
how come when it's inside the brackets it's like not, but when it's in front of the brackets it's like not?
It's like this.
This is like just a start. It means something different. Like just a start of the regular expression.
Okay, because I was looking at this thing about regular expressions and it said that indicates the beginning of string and that's a string right.
Mhm.
So,
It's its own creature, really.
okay.
I never use it, so for what it's worth, but knowledge is power now. If you ever needed to use it or want to do something advanced, that you know that regular expressions exist in MySQL. I don't even know if they do, and I guess you could use functions in Microsoft SQL Server and do regular expressions on text, like a text function on a column. But even there, I never really use it. But you know that it now that you know it exists and kind of how it works. That's why I don't go into too much here. It's part of the key of the classes to give you that basic knowledge to start doing it, and then it's just a lot of practice and even looking stuff up online to get what you need. Once you have the basics, then it's pretty easy to build on it with like any number of like online forums or searches, anything like that. Okay, go ahead and get started with the second hour. We went back and ran through the code. I think that was good to do. All right, scalar functions. This is really just a quick review of the different scalar functions. So you have string functions, concatenation, putting two of them together, length, replace, substring, trim, format. We'll see all those in action. Control flow is your logical functions, like your case. They're evaluated true or false. If and if null. If null is if the value is null, then it's true or else it's false. Date and time functions, a number of ways to manipulate and format dates. Comparison functions, numeric and math functions, your usual operations that you can do on individual values like ceiling and floor, rounding and truncating. You can also format them into different formats. One of the common one is to format it as money, if you were ever doing that for some reason. And then data types, you can cast them. So we'll go into a little bit more into that. That's important, especially if you have some, say you have integers stored as a string in a table, and all your values are numbers. You can cast that column as an integer, and it'll take the string values, it'll look at what's inside of it and change it to numerical value, which can be really important because you can't really do a sum on a bunch of string values. You'd have to convert it to numbers and then do a sum on it. All right, so this is where we'll start digging deeper into these. So format a number n to format it like this with commas, rounded to d decimal places. This is how you could do it. You could select format, and here's an example. You do it to 3 decimal places, and then you'll get the comma in here in the decimals. Some of these, oftentimes when you're doing a format, it's for like presentation purposes. If like you are getting a result set and you want to copy and paste it and send it to someone, like then they can more easily see like the columns in there instead of it being SQL output. Or you could use a dollar format, and like then it'll be in dollars and somebody can see it a little bit better. I don't use that a ton because oftentimes I'm importing it into something like Tableau, and then you can just format the number there. But it's helpful once in a while to do that. Do that out of SQL. You can cast. I was just explaining this. Convert a value of any type to a specific data type. By far the most common is either a number or date that's stored as a string, and then you could cast that as a date or an integer or a decimal or a double or whatever you want it to be casted to. Trying to think of some other examples. You could probably, yeah.
So you put the 150 right there, and you said instead of unsigned, you'll say something.
Yeah, you could say integer. I just chose unsigned there because it's a type of integer. It's like a positive integer. And you could do that, but usually it'd just be integer. Unsigned is just data type that's a type of integer. Unsigned would be all the positive numbers, all the positive integers. If null, returns a specified value of the expression is null. So this can be like on multiple columns, checking all of them from left to right. Return the first one. That's 500. So if this is just, I believe if this one is just null and it didn't have the 500, it would return null. Return specified value. Yep. The expression is, oh no, wait a second. I read that wrong. That's why I'm so confused. So it returns, this is an alternative value if the expression is null. So if you're going through a column, that's right. If you're going through a column and the value is down a column and you come across the null, it's going to put 500 in for every null. That's where we were talking about at the beginning of class, where you can impute some values if you know what the null values should be. Like if you know they should all be 500 or whatever it should. Maybe sometimes you even put null, and then you'd have like a NA there. You'd put that in character string. And then instead of it being null, they're just all NAs instead. Or maybe they are true zeros. You put all zeros in there. It's possible too. So is null the expression? It'll return 1 or 0 depending on whether the expression is null. This is what I was thinking about before. So if you do is null, it is null, or there's a null value, it will return a 1. Or if not, there's a 0. Which is useful in detecting the nulls that you have in a data set and what you should do. You could actually use this in a where clause, and then you could get back all the nulls. Although kind of a fancy way to do it, because I usually do just if column is null instead of using the function, but you could use the function too. And then coalesce, function returns the first non-null value in a list. So if you do these 3 values, or say these were 4 values, or these are 4 columns, if the first column was null and the second one along an observation was W3 schools, return W3 schools. That could be valuable if you have some type of currency, different currency values, and then just returning the first one. Can be useful to pick out the null values in your observations, and whichever ones would be out of the series be the first one to not have a null value. So you can see more numeric functions. W3 resources or W3 schools are always my favorite. And then for cast data types, it should be a different link. I'll update that and send that one to everyone too. It'd be good and useful to see all the different casts. Actually, let's go ahead and try to look that up. So if I just look my SQL cast examples, see, like this is like probably by far the most common is like the dates in a like character string, and then you convert it to a date. Let's see, MySQL tutorial, that one's probably pretty good. It's probably the link I meant to paste in the slide. Just have to be patient. Cast that expression or column as a certain type. So sometimes you'll also evaluate something that would be a decimal. Say they do 1 + 1 as unsigned and then divided by 2. You could cast that as either an integer or decimal. But there we go. Let's see if they have any other examples here. Mostly it's casting dates. You can cast a number again as a character. So you can go back and forth and then between number and character and so forth. There are a lot of options. I'll find a good cast resource on this so you could really see where a lot of different types of type conversions. All right. So let's go ahead and keep moving forward. All right. So numeric functions, filling in and converting GNP old values in world.country. So this is one of them where you notice there are a bunch of nulls here in the values for whatever reason in the GNP old column in the world.country table. So one thing you can do or select name as country, convert inside this GNP old to from world.country. So let's just run through these examples. I also like to see the original one and what it looked like before. So let's go ahead and do that. Okay, this is the one where we select name as country, then convert that from world.country. So here's one thing I want to do. I often do this. I do the unconverted version next to the converted version to see how it changes. So you can see now, that's why I did it. So I forgot why I did that actually. So I converted it and rounded that to 0 because all these decimal places, they were all just zeros in the database anyway. So to take off those zeros, we just converted, we rounded all these to 0 decimal places, so the integer, and then we converted them to an unsigned integer. And it gets rid of all those decimal places. Say I do this a lot when I'm cleaning data, so it'd be like the original version from the table and then my conversion that I do in the query, whether it's a case statement or some function that I used. Okay. So then there's replacing null values using coalesce 0. So what that's going to do is it's going to look to see, is there a value here? If there is a value there, we'll keep that value. Otherwise, we'll put a 0 in there. That's probably the most common use of coalesce is, say, if you either you have a column and if that's null, put in 0, or have multiple columns and see which one is the first column that's a non-null column. So go ahead and run that. And now you see with the nulls, here's the original column. And notice they're back to decimals because we didn't save this first one in a table or anything. It's just taking GNP old as it is out of that table and applies that coalesce function, but the decimal's still there. So now if you really want, if you wanted to, you could nest functions. Also, you could do something like this. It's also possible to nest functions. And then it did two things here. It took off the decimals from the last one. And then it also said coalesce, whether it's null or 0. So you can start nesting functions like you did in Excel. Sometimes, I guess, I would say to the point of storing values or storing values a certain way. If you didn't want to nest a bunch of these things, you could store the data in your own table and then just apply a bunch of updates to it or something in multiple steps. So first, maybe you do something like you would round it first, and then you would convert it to unsigned or whatever. If you really wanted to, I guess I would say, if you really wanted to store and maintain a certain way of formatting your data, maybe then it would be useful to state or store in a table instead of just a view. For me, views would work 90% of the time, unless I really want to like store some type of transformation or formatting or what I did with a table to make it usable, I suppose. Later on the last class, we will also see functions and stored procedures. And stored procedures are a way that you can save multiple queries and run them all in a row and then return your result set too. So that would be another way that I do it. And then I get just some of your own preference and creating your own tables and everything. All right. I hope I'm sharing the right screen with everybody. I think I am. I just saw a note from earlier and it reminded me. Yeah, I think everyone can see my screen. Numeric functions. Right, string formatting functions. So instead of just casting, string has a number of ways that you can format functions. You can concatenate 2 or more strings together. Like if I was just to do my first name, middle name, and last name, they put all those together. You could also imagine if these were columns, you would take first name and then concatenate with middle name and then concatenate with last name. And then you do that across all the rows for those columns. InString returns an integer that indicates whether the position of the first occurrence of the substring. So this can be useful if you need to know where to start to parse a string. So if you're looking for string, it's going to look through this string, and for the first instance of it, 1, 2, 3, 4, 5. So where this becomes useful is if you do a left or a right string function, you can tell it where to start. Say maybe I just want everything up to there, it'd be like a left 4. Or if you wanted everything after that, or everything after that, you could do like a length minus this. But also there's a mid function that you could use too, or a substring in MySQL. You could say, give me everything from this to the end using the length function. There's a lot that you can do here. We'll see some of these examples coming up. All right, so you can trim. You can remove all prefixes or suffixes from the given string. So usually trim, I'd use this for like blank spaces if the text has blanks at the beginning of or at the end. But you can also trim certain strings from the text. So say your text was leading text and you wanted to trim the leading from it. So you would remove that part of the string and it would just leave you with text. Replace. This is one of the more useful ones, especially with names or addresses and so forth. So say you had a string or a column and then you find something like ST and then you replace that with straight. Or there are all sorts of different abbreviations that you could replace with the name or your own abbreviation. And you can see here, if you replace the UR with an R, you end up misspelling W3 resource, but that's what you did. You replaced the U and R with an R. So what really replaces, I use that quite a bit on addresses and names and like Mr. or Mrs. abbreviations and stuff like that. Especially addresses are a big one to clean up and standardize. You can change it to lowercase or uppercase. So if it's lowercase and the string value is all uppercase, it'll change it to lowercase. Could be useful, especially when fields are case sensitive. Just change it all to lowercase. Length of the string returns the length of the string. So with my last name, it'd be length 8. That's valuable when you're doing mids or in strings and so forth. Say you want to get part of the string, the 5th character to the last, you do like substring 5 to 8, which takes you to the last one. you have a column and then what character to start at, and then how many out to go. So this would actually do, it start at the first one and then it would do 3. So you wouldn't actually use the length here. You would use, if you did the 4th one, then you do 4 and then get 4 characters like MANN. Let's go ahead and do a bunch of examples with these. That was kind of a lot. This is where I said that you could start using case functions early, like start to do multiple things, like replacing Arizona with the abbreviation, or if you had an int string, then do that rule. Create your own abbreviations out of it. So let's go ahead and run this. This is the one that we're doing, I think. Convert USC city names. Yeah, okay. All right, so I usually like to do, I like to put how it looks at first before you do anything, and then the district to state, and then say if name, if you concatenate those two, or wait, what am I doing there? Concatenate name. Oh, I see what we're doing. So we're taking the city and the state, and we're doing like a New York abbreviation, New York. So let's just go ahead and run that to show what it's doing. Okay. So you can see Los Angeles, California. It's taking that and changing it to Los Angeles, CA. So we are doing a few things here. On some of these, it doesn't work quite to do. On most of these states, it works to just do like the left 2 letters of the state, and that works for an abbreviation. But then a couple of these, like Texas, you can't do the left 2, right? Because it's TEX, and then the abbreviation is actually TX. Or for Arizona, you could go, if the district is Arizona, then replace that with the AZ abbreviation, just showing how you could use replace and then return it as a case statement. Or just when district is equal to New York, then use NY. So you run that. I guess we already ran it, but say it handles, I'd say the case statement like handles all of the exceptions that you'd have to the rules, or all of the rules that you want to put in. Say this one's kind of a silly example, but it shows you how trading the leading pen from Pennsylvania, then say PA. These are like all of your exceptions that you code as rules. Trying to see if we had a Pennsylvania one in here. We should somewhere. I probably passed it. After a while, you stare at data and you're moving fast through it. Your eyes kind of blur, or they start to cross. There's one. So that hit that rule. Trail the leading pen from Pennsylvania. When that's true, when district, when you take the pen off and it equals Sylvania, then the PA, that's how Pennsylvania abbreviation gets there. This one's really just to show how you would use you would use these different functions, or how you could. And then otherwise, if it goes all through all those rules and none of them are true, then the else is kind of like the default, you would say. Then otherwise, just take the left 2 letters of the state, and that'll be your abbreviation. Those are the only ones, I think those are the only ones I could find that didn't use the first 2 letters. What's that? Oh, did I mess those up? Where's some... That's where you would say you could do oops and then see. I didn't get quite all of them, did. Oh, did I just do MI from Missouri? Oh, it's okay. I won't nitpick it for now. Maybe I'll add a few more in the next time I do an example. Put a few more text functions in there to handle different things. All right. Let's go ahead and get through this, but that's how that works.
Is upper like uppercase?
Yep. Sometimes it's useful to just convert everything to upper or lowercase because in MySQL this is case sensitive. So like lowercase California is different than having the first letter capitalized. That's one thing I didn't mention is it is case sensitive. MySQL is. So when you're doing that, you have to have it capitalized the same way, or else it doesn't think it's the same string, which is reasonable the way computers think about things, but that's where you could just standardize it. If there's like inconsistent capitalization and things, just turn all the lowercase or uppercase. Right. Date formatting functions. There are a whole bunch of these. One of the most useful is current date. I use that in where clauses a lot. Where current date is equal to, this will return the current date in that format. Where some column maybe a system's producing records, you want to just see all the records that are equal to today. That one, I use that one quite a bit. Current timestamp returns the current date and time in that format. So you'd return this date, and then it'd also give you the time of when you're on that function. This is really useful if I'm running updates. So if I update a record, I can usually have a field in there that's like a timestamp field. And you put the current timestamp to show when it was last updated. You can get hour out of time. So this would be hour 13 because you get the hour out of the current timestamp. Date difference, do this a lot too. So say you wanted things in the last 30 days, you could do current date between current date and current date minus 30. And give you everything in the last 30 days. That often use that in a where clause also to limit what records are being returned. Day of the week. And really all of these are really useful. You'll find yourself using quite a bit of these date formatting functions. You just want return for all shipments on Sunday. So you do where your date field, you'd have some date field, and then you do day of the week is equal to 1 for Sunday. Maybe it's like a shipping date, and then you do give me everything that all the packages that shipped on Sunday. Day, month, year, kind of extension, day of the week. All those functions will return those as integers. And then the current date, that's the same one as right above. But there may be even, if I feel like there are even a few more than date functions in that, all sorts of functions. But these are all really useful, ones that I use a lot. Right. So date function, get the number of years since each country's independence. I'm going to go ahead and run the code. I think we're getting right to the end of this, which is good timing for hour 3. Being able to work on some of this ourselves. So right here, it's getting the current date. Oh, here, current date, a year. So current year is 2024. Independence year is 1919 there. So anytime, so we do a case statement to clean some of these up and create our years index calculation. So if it's independent year is null, then we just say years independent is 0 because it doesn't have an independence year. Perhaps it's never independent, or it's not really a thing, or there's no information on it. Otherwise, we do current date, year of the current date minus the independence year to get the number of years country's been independent. So you can see where these really become dynamic. Instead of having to calculate these row by row, you can get the year of the current date, compare that against the independence year, do a subtraction in a case statement to get the years of independence. And even if there's no information, then just set it equal to 0. Case statements are huge when defining rules and going through a bunch of criteria when cleaning up data. Or getting it, even it's not necessarily cleaning up data, it's getting the data the way you need it to be for analysis. All right, so we're getting towards the end of this lecture. So here's just a list of some of the common errors. This one's in SQL syntax, so this one's a little bit off topic, but I remember we tossed this in here, just common errors that people will make in their code, whether it's spelling of table or columns or values, or quotes, how you use that in MySQL, whether it's single quotes, double quotes, or backticks on columns. Converting data types, whether it's an integer as a varchar. How you're using that, oftentimes these will be stored as character strings that you need to cast as integer to be able to use it instead of adding them together. If you try to add those together, it'll give you a null value. An integer and a character just won't know what operation to do with those. The order of SQL clauses from lecture 1, joining on their own column, or over filtering on the where clause. So while cleaning things up, some of the common syntax errors that you might make in your code. So class 5 review, I have to put the goal in there, but the goal really of cleaning all of this up is like we stated at the beginning. It's to make this completeness, consistency, uniqueness, validity, and accuracy, so you can use that data for analysis for whatever purpose you need to use it. So whether it's removing unwanted observations, fixing those errors, or handling missing values. Now you have some of the tools to do that, whether it's through a case statement, wildcards, text wildcards, or text functions, or any number of functions to be able to clean up data. Will help you with all of these to be able to get that data where you need for your purpose or your analysis. As oftentimes when it comes from a different source, it's not perfect, and you'll have to do these things to be able to get it to where you need. And then just going down to the rest of the summary. The tools we learned, like I was saying, operators, wildcards, like functions, for straight text strings, case statements and logical functions, especially case statements with all of the different rules that you have for cleaning up a column. Removing duplicate data, we're familiar with that. Showed a few different ways you can identify it. And once you identify it, you can figure out ways how to remove that from either your result set or table. And then cleaning and formatting strings, numeric and datetime data. That's probably one of the things I do the most out of that. 75% of the time that it needs cleaning is getting like strings and numeric and datetime and date formats where you need it to be. All right. So there is an additional resource here if anybody's interested in how to clean data with Python. We already mentioned data scientists spend a large amount of time cleaning data sets, and cleaning constitute 80% of their job. I'd probably agree with that. What's useful, I don't know if anybody's used Python, but you can write Python. It's a programming language, but it has data packages where you can turn everything into just a like sheet or a table, like a tabular data set, like you would in SQL, and then you can do a whole bunch of programming operations to it also. In Python, you use string to clean columns, and then you could use regular expressions inside of that string. So it's kind of like the replace function in SQL. You can map a whole bunch of, you can create your own functions and then map it to a data frame yourself, like custom cleaning methods and routines. See, renaming columns is really useful. Often they're the way you want them, and you can skip unnecessary rows so you can use wheres in it. So that is it for this lecture. I'll give everybody a break. I forgot, does this class, do you do Python next in the series? Is it in data engineering? Because, yeah, that'll give you a heads up, because oftentimes you'll create like what you call data pipelines and multiple step data pipelines, and those will be in Python, like your transformations or cleaning up data. Personally, I like to clean it up as much as I can at the database level using SQL like views and stuff. So it makes it easier once you get it into code, or you get it into Tableau or something like that. But there are a lot of things that you can do once you get it to Python and get it where you need to. Some engineers just prefer that too, especially data scientists. But I like defining it at the database level too, because then it's more reusable. People can just go to the view and see what you already did instead of having to look up 50 different pieces of code that you created. Adds up over time. All right, so after the break, we'll take, let's go ahead and take 15 minutes, come back at 8:25. I'll show you some example exercises. You can get a head start on homework 3. I won't make this won't be due until next week, and this will be combined with class 6. But this will give you, I'll give you a primer on what we're doing here in this for class 5 and homework 3. When we're back, go ahead and take 15 minutes. Be back at 8:25. Hopefully I'm not missing anybody online. And also, I'll give everybody a little bit more time for handing in homework too. The biggest thing is with the homeworks is just testing everybody's knowledge and making sure everyone's progressing. And since SQL builds on itself, and this guidance, if you miss anything, just guiding you in the right direction. So more important that you eventually finish it than it is due date. Yeah. Yeah, I take 15 minutes here.
Huh?
I can take 15 minutes here with you after. Yeah.
Right now, I have, okay, I got the right sales basically.
Yep.
The sales, right. Right? Are they supposed to be the same?
I think they're different. So you imported all those tables?
So I put it these in my see. And it's really trying to do games,
Yeah.
console games on the USC but it wouldn't work for you. And so they really say,
Did they just take you long to?
all the stuff went on there. It's just the way that it was showing up. It showed up like this. And then I switched it to the one to the wrong view
Yeah.
But this, it won't let me insert it. And I was figuring because these quotes or something like that. I don't know. It's just not written the same way or what it is or
You know, there's some option in here to change it to like a MySQL format.
yeah, put it on my CV. I'm trying to click everything. Okay, what is this and like the ones at once? Switching everything around. Like, how do I get the data?
Saying you tried the import table wizard, Dave? And that took too long. I think
It wouldn't work. It did the first two ones, and then I said, okay, we're trying to, input.
Can we try it one more time? Try one of these. They worked okay for me to do it that way instead of going through the table convert website.
It would bring it up before, and I know next, on that, and then it's like, it couldn't run it with the air.
Here's one thing you can do. I can do for you if you're having a hard time importing it. I thought about this for everyone. I can just give you access to the consoles schema that I created with all the tables imported. Let me just do that. I'm just going to put this in Slack.
But I still have to input it though?
No, I'll just give you access to the tables I already imported because I don't want it to be like something that stops you. Yeah. I'll give you access. I had thought about maybe just giving everybody access to that. Let's see. And that way you don't have to bother with those CSV files and it like not working and not being able to do the rest of it. Yeah, no problem. Okay. Let's see. Okay, we'll give access to you select access to the console schema. Okay, so now you should have, if you refresh, you should have access to a consoles schema. I'll have all the tables in it.
See, it looks like you put.
It could have been in there and you hadn't refreshed it. Like it imported and you just hadn't refreshed it or something. Yeah. Sorry, it's painful for you. Sometimes the data imports are kind of painful. Working with data can be kind of painful sometimes. Okay, I think I said I would start it up. Start at 8:25. Let's see. Oops, where am I? There we go. Cleaning data. We'll come back to work here in a minute. Okay, so oh, that big text field to parse out. It's okay. Just work with that.
Well, I was just gonna like make this column so that I can do that stuff.
I don't really mind. Like I said in the in the in the channel, is that it's more about your outcome than it is your code being exactly the same as mine. So I like just thinking about math. I'm a math guy, and in school they always make you do math in a certain way. But really, like, that's because it's like easier for the teacher to grade it and everybody doing it consistently. But like, but if you can get to the answer a bunch of different ways. It's not necessarily just one way, and that applies with SQL. It's in high school. Huh?
I was like, well, I guess I could just be like, I can just use the column.
Yeah.
I just like the idea is to learn how to like cut them apart and trim them and stuff like that, which
Sure, you could create like
just do something different.
you could take the big text string and cut it into multiple columns. That's pretty legitimate. Like, especially if it's like this big one, and then they're like, you can tell what certain parts of it are.
Yeah, but that's like I already did that. Like, so.
Yeah, that's okay.
So, I'll just-
Or unless it like totally crushes like doing any cleaning of the data.
Well, I mean, I like put it in.
But then
and
you did
I
something
literally,
smart, I
like,
guess.
Physically, like, edit it in the code to make different columns because I thought it was just like messed up. I'm like, oh, that's what
Well, yeah, you could either do
I
it
thought I
when
needed it for the thing last time.
you can either do it as you're loading the data, or you can do it later.
Yeah.
It's actually something we'll learn about too. You're welcome. I hope I'm helping you and not making you hate it. It's awesome. You have skills now, data skills. You have data skills now. It's awesome. The world, like, it's at your fingertips. See you next time. Oh, the next class will be everybody's online because this room is booked. Okay. See you, Zanelle. Okay. 8:27. I'll go ahead and go through the assignment here and then some examples. I don't have in this lecture notes a page where I did examples this time around, but I do have a file that I sent to at the beginning of class. It's called Class 5 Examples Formatting. There's just a whole bunch of examples in here of using case statements to format or create your own new column. You also have cleaning data like US regions and using different wildcards, identifying duplicates in different ways. Numeric formatting examples. So at the beginning of class, I said that the from keyword is needed in every query. It's the only exception is when you're doing this as a bunch of values. So this is actually just a bunch of values. You can put this in the select clause. like this decimal, where you can cast 150. These are actually all just constants, so it's going to return as one row. So if is null is null, and then your coalescing values, it's going to show, it even shows in MySQL each one of these and what they did. You have a bunch of string formatting, date formatting, numeric functions, and formatting. Or this one, yeah, this you use to convert instead of cast on that one. Coalescing 0 when null values exist. And then other string functions you use in a case statement. I guess this is a state example we started to use. If anybody wants to do that the rest of the way out, that'd be a good exercise. It's missing a, when you do the left too, there are actually still a couple errors in it. That'd be a good one to finish out from start to finish. And then date functions, using like current date and doing the difference in the year and so forth. So some of the examples from the lecture, but some additional ones too. Play around with these a lot and continue to add and explore. Be a good use of that. All right. So homework 3, I want to do a primer on this one. Those are all the answers actually. So I want to bring up the template that I sent before class. There's a template for this. Oops. Actually, did I not create a template for this? I thought I did. Okay. Well, I'll send a template out right after class. The idea is that we have this table, the pre-order chart. I'm going to show you what this looks like in its raw format. So it's USA pre-order table. And what you'll do is create this view. The pre-order chart view is a view that you'll create from this table. And I'll show you what this pre-order table looks like. It should be one of the ones that you imported from a data set. That's why I said, if you're unable to import some of these, let me know and I can give you access to the table, because it's or access to my imported version of it, because it's more important that you have access to the data than it is to wrestle around with the import. So we'll just select star. I'll show you what this USA pre-order table looks like. So it has a game, and you're going to work on this game console company genre column. And you see it is separated by commas, but it has a whole bunch of values in it. So it has like game, console, company, genre. You'll sometimes see columns like this, especially if a system produces it. They're trying to save space or whatever, and they just end up concatenating a bunch of fields, and they use some type of separator. But in our homework, we're going to do some things to create this view and then clean up the data. So when you clean up the data, it's going to end up looking more like this. So that's separated out. So changing NA values, each launch column to 30. Creating new columns, like console, company, and genre fields based off of that long field that you created, or that we looked at in the previous file, this one. So really like parsing and separating those out. What else was in here? Fill in the game and genre column with relevant values. And then calculating the difference between today and the date of the pre-order list was last published. So I'll give you a number of days since last published. Then the last part, let's see, fill in genre. So let's see what I do here. If anybody needs hints as they go along or they're working through this or something doesn't make sense, please let me know. Because I'd select genre from the week's launch that you created, then summarize by total. So yeah, that's actually, this was number 2. So once you've created this view and cleaned it up, then you summarize it, and then you summarize it, and then answer the question. So really it's an exercise in like the data's come in this raw format, and you need to separate it out to be able to answer your question, which is really common. And it did this and created that in a view. Instead of putting it in consoles, please put it in your given schema for the class. I'll go ahead and do your best on it. It doesn't have to like be the same as this. But as you do it, just that it ends up parsing out, and then you're able to answer this. You're able to answer this question at the end. Just give it a try, and if you have questions as we go through or need hints, I'm happy to drop hints in there. I'm gonna let everybody give it a try and see how it goes. So I'll go ahead and create a template. For this and drop this into Slack. Okay, we're getting better at having working time here on the last hour. All systems were go today, and we flew through it. So do template. So the question number 1 in homework 3 is going to take you the longest, and then if you do everything right, 2 is a simple query. And class 6 will be added to homework 3. I just wanted to give everybody a start on class 5 if they wanted to do that for homework 3. So class 3, the homework 3 will include class 5 and 6, and then they'll be due next Monday. And I won't review homework 2 yet because we'll give everybody a little bit more time, and then we'll review that at the end of lecture on Wednesday. Although it's looking, everybody's pretty close to being done. We'll just give everybody a couple extra days. So go ahead, send everyone. So this is a template for homework 3 for the class we just covered. Just drop that into Slack. So Bianca, you had errors importing the data from homework 5. If you did, I'll give you access to the consoles database with the data I was able to import, so you don't have to worry about it anymore. I think it's more important that
it's in there.
More important.
Like, I don't know if it's like I don't know, but okay.
If it gave some errors too, yeah, it could take a while to like go through and figure out what those errors are. I'd rather just give you you've already given it a try, which is good enough for me. Just give you access to them so you can keep moving forward. So I'll go ahead and do that now. So if anybody else has the same challenge, I'll just give you access. Just considering giving everybody access to it anyway, just so if you do something to the table, you can just restart from fresh. I'll do that after class. But wait, I want to give you access to consoles. I'll give you select access so you can use the data out of it. Okay, Bianca, you should have access to a schema now called consoles. And that was data I was able to load out of all the data sets that you need. If anybody has questions or things they want to work on, just let me know. Happy to help. Could work on a couple of those. So we were talking about do one for cast data types. W3 schools is once again a pretty good example of the MySQL data types you can cast to. So it has a syntax, so this would be the column as the data type. So the value is the value to convert, or the column. And here are all the different data types you can cast to. Also gives information on the convert function, which is similar to cast. I think it's only slightly different. In that it does the same thing as cast, but it has slightly different data types that you can cast to. Oh, and it has this character set along with it. I'm not exactly sure what that would do. You can cast sometimes strings. You can do it in different formats, text formats, and then use it for programming, but it's kind of fancy. I don't think I've done it in SQL. It's usually some default type. Okay, so I updated that in the slides. It's gonna go. There were two things I was gonna do. Have to look that one up for Ronnie. I'll have to do more research on that one. With the constraint on the quiz. I'll do that before I give feedback to everyone on their quiz scores. I may owe everybody an extra point or partial point or credit for that answer too. And then there's one more thing. When did you bring something up in class today that I should look at?
It was the one I didn't really know was insert into it and select. I didn't see it in my notes at all, so I'm not sure that that's up there, right?
No, I'd bring it up real quick. It lecture 3. Lectures. Let's see. Lecture 3. It was it's like the query also that we looked at copying the table, but we covered it. This one is like inserting values into a table from a query. So you have the insert, and then you have this query underneath of it. So you can take a result set like this, And instead of doing like each as an individual value statement, and if you have the results set, it'll just insert these one by one into the table. Which is much better than like having to write each one out individually. As I showed your comment there, I think it's common that people are having a hard time with the import. I think I covered it. Off camera. When was that? The last Wednesday? Because I had struggled to find it at first, but then I found the import wizard. And then I talked about it a little bit at class, but I don't think I recorded it. But I did. Oh, I did put some of the directions in the channel. How to do it. It was like a sidebar. Here we go. Maybe this was it. But anyway, Maz, I can give you like one of the big reasons why I'm extending it is because a few people had a problem with the import. I can give you access to the console schema so that you can use the data as able to import. I don't want import to be a barrier into finishing the rest of the assignment or the rest of class. I just wanted it there as an example of how you might be able to get data from like a CSV file into the database. Okay. Let's go ahead and add you right now. I think I might just go through this and add everyone. Okay, give you select. Access is granted. Just like magic. You're welcome. Did I forgot to make a slide over what the next class is going to be? I usually do that. Next class is about database design. Now that we have all the skills, SQL skills, and we've put them into practice. Next one will be about structuring and modeling data. So how you create a database and database schema that captures transactions the way you need them to be captured out of the system. And then how do you take that and design it and use it for analytical purposes. So this one is probably, out of all the classes, the next one's probably the most theoretical, but you come across these in business as far as I'm talking about these database designs, and someday you'll even have to look at a table like this to be able to know what the relationships are and how to get certain pieces of data out of a system, and then translating that over to your analytical data store. So not expecting anybody to know or be experts on this after the next class, but at least being familiar. It's being familiar with database design concepts and how those might apply to wherever you work or wherever you use these skills someday.
It's like, do you do so look at the example, and there's a where statement. Do you read that here? And if so, what is the field that we're
Do you need a where statement? Let me see. So let's take a look at this. I don't have a where statement. I'm just cleaning the data columns. So I'm just taking the table as is
I just want to
and then applying.
So we're just.
But of course, I mean,
Table as this table from. Right?
yeah, USA pre-orders table. Yep. So yeah, the thing about cleaning data is not only does it take the technical skills, like it also takes knowledge of the data and the systems and the processes that create the data and like what you should do with it, how to best represent it. It's a part that's can be the most valuable part of a data. That is probably, I would say, the most valuable part of a data analyst is not just being able to work with the data, but also knowing how to represent it, how to fix it up and report on it and apply rules and represent it and present it, whether it's data or analysis or through Tableau. Tableau is just another way to represent data as information. SQL I just see as a skill in the toolbox that allows you to get there in a much more effective manner. A valuable skill in itself, but an even more powerful skill set as you learn more about the data and business rules and processes to go along with it. and you understand the challenges and the problems and how to represent data in the way that it needs to be for that problem. Is anybody still there? Right, everyone who's still here, I'm going to end the stream. I'll still be here for 30 minutes, or as long as anybody would like. I'll go ahead and end the stream, conclude the stream here. So that is it for Class 5, Cleaning Data with SQL. My name's Jeremy Bergman. The next class is Class 6. This will be where we start to model databases and really the right architecture to be able to capture transactional data within relational databases and turning that into analytical data that we could use as data analysts. Until then, let's sign off, and thanks everybody for this class.